Well, the cousin of the subcritical pitchfork bifurcation is the supercritical pitchfork bifurcation, and it basically runs in reverse. And so let's now look at the supercritical pitchfork bifurcation. The generic form for such a bifurcation is given by the equation x dot is equal to rx minus x cubed. And once again, the fixed points for this equation of motion are x star is equal to 0 or plus or minus the square root of r. And so let's look at the equation of motion itself for various values of r. So once again, we're going to plot x dot as a function of x. So we'll have three such plots for the three different possible values of r. So first of all, for r less than 0, then the linear term reinforces the cubic term, and we have something that comes through the origin with finite slope and goes off to minus infinity. So this is a stable fixed point, flow towards a fixed point. When r is equal to 0, then we come through the origin with 0 slope, just kissing the origin like this. And so we have a marginally stable fixed point, so slow flow on either side of this. So this is for r equals 0. And finally, for r greater than 0, then when we plot the function itself, we're going to get a cubic equation that looks something like this, with stable fixed points at plus root r and minus root r, and an unstable fixed point at the origin. And so the flow looks something like this. And once again, we can then draw the bifurcation diagram that summarizes the fixed points as a function of the control parameter r. So let's plot again as a function of the control parameter r, the fixed point value is x star. First, let's look at the fixed point at the origin. So for r negative, this is a stable fixed point, and it becomes unstable when r is positive. And similarly, if we look at the non-zero fixed points, there's none for r negative, but when r is positive, two fixed points are born and gradually move away, and they're located at plus or minus root r. And so there's a parabolic region, plus root r minus root r, and these are stable fixed points. And finally, we can fill in the flow pattern. And so for r negative, the flow is always towards a fixed point. So the flow looks like this. For r positive, the flow inside the parabola is reversed, and so we're being pushed away from the unstable fixed point. But then we're outside the parabola, we're pushed towards a stable fixed point, and so the flow pattern looks something like this. And again, it looks like a pitchfork because a single stable fixed point for r negative becomes now three fixed points, one unstable and two stable. And it's when r passes through a critical value which happens to be equal to 0 and increases beyond that point that you have the bifurcation occurring, and that's why this is called a supercritical pitchfork bifurcation.